All right, in this video we're going to talk a little bit about domain and range. So when you think domain, you want to think x values, possible x values. Range, you want to think y and possible y values. I'll just give you a couple of examples of equations and graphs. So say for instance I have a linear function. Well, let's go 2x minus 3. Are there any restrictions in what I can put in for x? I don't think so. You can put in 0, negative numbers, positive numbers, square roots, whatever you want. So in a linear equation, there's no restrictions on x. So for the domain, you'd say something like x is an element of the real numbers. Another way you can say that x can be anything is you can say, well, you can start x is at negative infinity and go all the way up to positive infinity. And so anything in between there. Both of these mean the same thing. X can be anything. Okay, now y for a linear function, because x can be anything, in this case y could also be anything. When you're looking at a linear function like this one might look something like this. So this line keeps going up as high as it wants, and this one keeps going as low as it wants. Therefore the y would be the same thing. So the range for a linear function like this would be y is an element of the real numbers as well. And again, you can say negative infinity to positive infinity. That would be the range of y values. Now, if you're taking a look at other functions, say for instance, thanks Caitlin. Okay, for instance, say I'm doing a quadratic function. So say y is equal to x squared minus 5x plus 6. With this one, I can probably put anything that I want in for an x value, but depending on what I put in there, there might be some restrictions on what y is. For example, so I can put anything I want in for x, and this one, let me think, this function is going to look something like this. So it's going to be a parabola that looks something like that. I think it crosses at 2 and crosses at 3. But there would be an extent to which this thing goes down. So for x's, I can go as far left and as far right as I want. So this would be the same as my domain for this one. But my range, I could only go down to a certain point. And if I wanted to find that point, I could find what the vertex is and say that my range is anything above the y value of that vertex. Okay, fairly difficult in this case here because you'd have to find the vertex, but it's hard to see what the restrictions on y would be. Like I'm thinking you couldn't have a y value like negative 10. I don't think that would work. But negative 1 might be in the ballpark. So to figure it out, you'd actually have to find out what the vertex was. Now, if you're starting to look at rational functions, so stuff like this, suddenly you get some restrictions on your values for x and for y. So, for example, on the bottom here, I cannot have 0. And so, let me just write that. Can't be 0. It's illegal to have a 0 on the bottom of a fraction. You can't divide by 0. So in this case here, you would say, well, x can be anything. X can be an element of reals as long as x isn't 0. Another way you could say that using this kind of notation is you can say, well, you can go from negative infinity all the way up to 0, not including 0, and you can go from 0 all the way up to positive infinity, but you can't, again, include the 0. And you say it's a union of those two domains. So from negative infinity up to 0 but not including, and from 0 not including all the way to positive infinity. Now what happens if you have one like this? Same kind of thing, right? You could put a 0 in for x there because 0 minus 3 is negative 3, but what number could you not put in there? Hopefully you said 3. So in this case, yeah, you could say x can be anything, just don't make it 3. So you could say x cannot be equal to a positive 3, or you could say go from negative infinity all the way up to 3, and from 3 all the way up to positive infinity. Okay, so that'll give you your yeah, that gives you your domain. In this case, for range, probably you can have any kind of range. You might have to graph that, but you might want to look at range when you graph that. Probably y cannot be equal to 0. So probably when you're graphing this, there'd be an asymptote. I'm not exactly sure how this thing would look when you graph it. I want to say it looks like this. And like that. Something like that. Where this value right here is 3. And then this is an asymptote. It comes close to the x-axis, but never touches it. And so x can't be 3, and y can't be 0. So that brings us into talking a little about asymptotes. So asymptotes are lines that graphs can't cross. So when you draw a normal inverse function, it looks something like that. That would be y is equal to 1 over x. And in this case here, x cannot be equal to 0, right? And so this line of, or not that line, sorry, this line here, the vertical one of x equals 0, that becomes an asymptote. So whatever number you cannot put in for x on the bottom of a fraction, that becomes the asymptote. So for example, if I had y is equal to something over x squared minus 5x minus 6, and I'm looking to see what the asymptotes would be, I could look at this, and this one will look different than this graph here. It'll be a different kind of graph. But I could factor that to this, and then I could ask myself, what can x not be? So in this case, you can't have x as being a positive 6, nor can x be a negative 1. Okay, so those would be, if you're looking for the domain can be anything, just don't make it 6 or negative 1. But if you want to know what the asymptotes are, the asymptotes, so the lines that this graph won't cross through, will be x is equal to 6 and x is equal to minus 1. Well, so that should have been not equal to. But the asymptotes are those lines. So on a graph, x is equal to negative 1 here and positive 6. There's imaginary lines drawn there. And the graph can come up and approximate those things. I'm not sure how this graph looks. So the graph can get close to those lines, but it can never touch them. So it can do anything it wants in between here, just don't let it cross those two lines. Okay, hopefully that helps you out on the idea of domain and range.